Imagine flying faster than the speed of sound over a major city like Miami, but no one on the ground hears a thing. No thunderous boom, no rattling windows, no startled faces looking to the sky, just silence. For over 50 years, that's been impossible. Every time an aircraft pushed past Mach 1, it dragged a wall of noise with it, a shockwave that banned supersonic flight over land and grounded the dream of fast global travel. But that may have just changed because NASA and Lockheed Martin's X-59 has flown. A jet so strange-looking it seems pulled from a science fiction sketchbook, designed to do one thing no aircraft has ever done before: break the sound barrier quietly. You see, this isn't just another X-plane. It's a test bed for the future. Not only for commercial flight, but for military aviation, too. If this technology works, it could mean stealthier strike missions, faster response times, and a new era of supersonic speed without the noise. The question now is, how did we get here? And why does this flight matter more than most people realize? For as long as humans have taken to the skies, we've chased one thing: speed. From Chuck Yeager's first supersonic flight in 1947 to the sleek Concorde streaking across the Atlantic, each generation tried to go faster, higher, further. But there was always one problem: the boom. That explosive crack of pressure wasn't just loud. It was actually destructive. Windows shattered, livestock panicked, and politicians heard from angry voters. By 1973, the United States had banned supersonic flight over land entirely. The dream of crossing the country at twice the speed of sound, well, it was grounded, and so for decades engineers tried to tame that noise. But every design hit the same wall of physics. The shockwave that follows an aircraft at Mach 1 doesn't care about your intentions. It's just raw energy unleashed into the air. The result: supersonic speed became a luxury that was confined to ocean routes and military test ranges. And as the Cold War ended, that chase for speed gave way to stealth, efficiency, and cost. The Concorde retired. The SR-71 was parked in museums. Supersonic flight outside of military aircraft became history until now because NASA and Lockheed Martin believe they found a way to reshape the air, to stretch and smooth that shockwave into something that the human ear might barely notice. And the X-59 is their living proof of concept, machine that's not built for war or for records, but for silence at Mach 1. You see, the X-59 isn't a prototype for a new fighter or even airliner. It's something rarer. It's a flying experiment that's built to change or at least bend laws, not win wars. NASA calls it the QueSST, and that's short for Quiet Supersonic Technology. Its mission is simple to say, but incredibly hard to prove. It's to demonstrate that an aircraft can fly faster than sound without producing the explosive shock that's been banned over land. And if it works, the X-59 could rewrite the federal aviation regulations that have been in place for over half a century. And to get there, NASA and Lockheed Martin Skunk Works designed an aircraft that looks nothing like anything in the sky today. It's a 99 FT Dart with a cockpit halfway down the fuselage. No forward window and a nose so sharp it seems to vanish into the horizon. Every curve, every angle, every panel is sculpted to spread that sonic pressure wave into a series of gentle ripples. When it finally goes supersonic over the test range, microphones will be scattered across small American towns, and they'll record what people actually hear. And if those recordings sound more like a door closing than a shockwave going off, NASA will take that data to regulators and say, it's time to bring supersonic back. But there's another layer to this mission, one that military planners are watching closely. I mean, this is a Lockheed Martin aircraft after all, right? Well, it turns out that if you can do Mach 1 plus without alerting everyone below, you can imagine what that means for reconnaissance jets, strike aircraft, or even future air mobility operations. The same physics that will make flights quieter will also make it stealthier. And if you've been following the stealth arms race that we cover on this channel, well, it's no longer just about radar, but heat emissions and sound detection as well when it comes to stealth. So this isn't just about civil aviation. It's about unlocking a new domain of speed, one where silence becomes a tactical advantage. Now, how did we get here? Well, after years of simulations, wind tunnel models, and one delay after another, it's finally happened. On a cool California morning at Lockheed Martin's legendary Plant 42 in Palmdale, the answer is always 42, right? If that location sounds familiar, well, it's because it's the same airfield where the U-2, SR-71, F-17, B-2, and B-21 were born. But on this day, on the ramp set something entirely different. Long, sleek, silent. The X-59. Its single GE F-414 engine, a proven workhorse that's the same core used in the F-A-18 Super Hornet, came to life with a smooth, metallic roar. Chase planes rolled into position. The tower cleared the flight. And at 11:36 a.m., the X-59 accelerated down the runway for the first time. For a moment, it looked almost fragile, a glider stretched to the limit of engineering. But as the nose lifted, the jet rose cleanly into the desert sky. Cheers erupted from the control room. For the first time in history, the sound barrier's greatest enemy, sonic boom, had met its quiet challenger. The flight lasted just over an hour. Now it did stay subsonic. This was done to test systems, control response, and stability. The goal for this first flight wasn't speed. It was validation. Every gauge, every sensor, every heartbeat of data would prove whether this strange-looking aircraft could actually fly the way the computers promised. When it landed, the test team knew. The journey that began with Chuck Jorger's thunderclap had just taken that silent step forward. But this is only the beginning. The real test going supersonic will decide if the X-59's promise holds, and that's where its design secrets come into play. The X-59 looks nothing like a normal airplane. And well, that's the point, pun intended. From tip to tail, every inch of it was sculpted to bend the very air around it. At 99 ft long, it's about the size of an F-15 Eagle stretched like taffy. That absurdly long, needle-sharp nose isn't there for style. It's there to actually reshape shockwaves. When most supersonic jets punch through the sound barrier, they form one brutal shock at the front and another at the tail. The two combine into the classic sonic boom. The X-59 shape, however, splits those shocks into many small ones that scatter before they reach the ground, turning the boom into a thump that NASA engineers claim will be roughly as loud as a car door closing. Even the cockpit is unconventional. The pilot sits roughly halfway down the fuselage with no forward window. Instead, an external vision system, or EVS. This is a high-resolution camera feed that's projected onto a 4K display, gives the pilot a synthetic view of what's ahead. It's like flying a supersonic jet through augmented reality. Now, underneath that single General Electric F4 and 4G engine provides the thrust, pushing the aircraft to Mach 1.4 in testing. Theoretically, that's the same power plant that's used in frontline engines. And this is proof that this tech isn't some distant science project. It's built from parts already trusted in combat aircraft. And then there's the data. More than 500 sensors embedded across the skin measure pressure, vibration, and airflow, feeding NASA terabytes of information about how the air reacts to the jet's shape. It's literally a flying laboratory wrapped in titanium and composites. Now, what Skunk Works and NASA are learning from this one-off could shape every supersonic design that comes next, commercial or military. Because if you can actually control the shockwave, you control the future of high-speed flight. But that raises a bigger question. What are we going to do with this technology once it actually works? That's where the implications get really interesting. It's one thing to show up with theory and even wind tunnel testing for a design to show that it can work. However, it's another thing altogether to take a prototype to the skies. Because of this key moment in aviation history, this makes the X-59's flight more than just a test. It's actually a statement. For 50 years, supersonic flight has been something that we had, and then we lost on the commercial side, because of those sonic booms and noise complaints. At the end of the day, the technology worked, but the world just wasn't ready for that noise. You could almost say it was the aviation equivalent of an angry HOA, sort of like an air Karen. But now, for the first time since the Concorde's retirement, that could actually change. NASA's data proves that a sonic boom can be reduced to a soft thump. The FAA and international regulators could lift the ban on supersonic travel over land. Just imagine Los Angeles to New York in 2 hours. London to Tokyo before lunch. A generation that's been raised on delayed flights and crowded cabins might once again live in an age of speed. And the military, well, of course, they've got a vested stake in this thing taking off. Because quiet supersonic flight could transform reconnaissance and strike operations. Imagine a high-speed aircraft slipping across contested airspace, its shockwave too faint to give away its position. Or a future tanker and logistics aircraft that can sprint at Mach 1 to support a flight half a world away. What NASA's calling quiet could become what the Air Force calls Stealth 2.0. But there's more than strategy at play here. The X-59 represents something deeper, a reminder that innovation isn't always about bigger engines or higher speeds. Sometimes it's about making the impossible acceptable. And if this experiment succeeds, the sky will sound different. The next boom you don't hear might mark the beginning of a new chapter in aviation. At the end of the day, the X-59's first flight wasn't loud, flashy, or headline-grabbing. And that's exactly the point. For the first time in aviation history, quiet was the breakthrough. Decades of engineers, pilots, and dreamers have chased the sky's limits. From Jorger's thunderous boom to the stealthy ghosts of the Cold War, and now in the California desert, a needle-nosed jet has whispered a new chapter into existence. If these tests ahead prove successful, the next generation of aircraft, military and civilian alike, could fly faster than sound without disturbing the world below. And that could mean that the dream of supersonic flight isn't coming back. It's coming back better because sometimes progress doesn't roar, it hums. If you like military aviation, cutting-edge tech, and stories like this, make sure you're subscribed, and join me as we follow the X-59's quiet revolution from the test range to the real world. And next time, we'll take a look at the aircraft that could take this technology to the next level. Fighters and bombers that are built to break the sound barrier without ever breaking cover. Stay tuned.